Thank you for having me. My name is Oliver Schiebel. I'm the CEO of hscale. Our ambition is to become a European gigawatt platform. What are we? We're a data center developer. We build data centers for large-scale customers, obviously like hyperscalers. And I will be talking to you today about AI-ready data centers. And currently in the market, you always hear about the 3Ps, the 3Ps being power, plot, permit. That is one of the biggest issues. It's probably discussed on every conference. And to be fair, the most constrained P at this point in time is probably the power component. We are in a lucky position that we've already secured a portfolio of a gigawatt of capacity, so we have substantial powered land available. So it's maybe not the most concerning topic to us, but something else is. And we're going to talk about this specific topic and not about the 3Ps. So what are we concerned about and what we think is a key topic for the future? The key topic is how the white space evolves over time to understand how you want to design your data center. What does the customer want to put inside the data center is the component that is changing. So what we had in the past, obviously, and there's this floppy disk that some of you may not even know anymore, it's reflecting what we did in the past. So the first data center I ever walked in was probably like 15, 20 years ago. It was a carrier hotel. It had 250 kilowatts of load, and that was deployed across 500 racks. And they were only meant to communicate with each other. They all belong to carriers. So what we had back in the days, quite stable compute, storage, and network components that evolved over time. Where are we today? What we see today is that we have further evolved computing, network, and storage unit, to a large extent still air-cooled, but we also are at a point where if you're on the road, some are now taking the highway with GPU deployments with high-density racks. So what we see today are high-density compute requirements that require 40, 80, 100, 125, 150 kilowatts of capacity in a single rack. Where in the past, you could probably say that the air-cooled racks would do 8, 10, up to 20. We now deploy air-cooled racks up to 30, 35, some maybe even 40 racks. But the challenge that we have is that looking at the potential future, obviously those AI workloads will drive even more powerful GPU deployments, so even more powerful compute requirements, but the network and storage component that you deploy pretty much stay the same thing. So those are still air-cooled, so those are still at densities of around 4 to 5 to 6 kW per rack. So what does that mean? How does the white space evolve? And before we discuss that in further detail, it's maybe also important to understand how the whole data center is affected by the change. So in the past, what you have, for example, in a 10 megawatt data center, you had approximately 1,600 rack positions, so a huge white space, and you had only a relatively small amount of cooling equipment, of secure power supply, and of infrastructure components. What is now changing and evolving through AI and high-density chip loads, it's becoming the opposite. In a world where you can deploy 10 megawatts of capacity in 10 1-meg racks, you have 10 megawatt in just 10 racks and no longer in 1,600 racks. So that is the challenge of the future in terms of the compute requirement, but you still have the issue that some of the network and storage equipment still stays the same. And it's very important to keep that in mind, because if you want to train AI to understand which cat is yours and what the cat's name is, the easiest way to do that is to show the AI 1,000 photos of cats and another 1,000 of your cat to distinguish which cat is yours. So you need storage and network for the compute to work. that requires a more flexible future. So the data center of the future will not just be a huge infrastructure building with just 10 racks of GPUs next to it. The data center of the future has to be flexible because it has to be able to house all the components: network, storage, and compute together. So the future data center has to be much more flexible. It has to be built of building blocks, like this Lego car, and it has to be modular. Modular not to an extent that you think of shipping containers or modular components that you stick together, but modular as in you try to reuse the same building, the same generators, the same equipment for different kind of setups of infrastructure deployment. I'm German, so obviously there has to be a car, and the next example also has to be a German car. And this specific picture shows the Volkswagen MQP platform. So what it does, it's more or less one base platform that can pivot to any potential size of future vehicle in some range that Volkswagen will produce. The same platform can house every kind of engine concept in the same platform. So it allows the business to deliver to multiple customers, tailored to their specific needs, on the same platform. So the idea here is very simple. You have a standardized product that can easily adapt to a specific customer requirement. And that, we believe, will drive the future. We specifically do this with a product or a concept that we call Magnus. Magnus refers to our baseline design, and I think what is evolving, what is changing, we saw in the past a lot of standardized data center where you could have economies of scale by rebuilding the same building all over again, all over again, all over again. What is different with the Magnus philosophy is it's the Volkswagen approach. So we have one base design that is liquid cooled first, that can pivot to air, it can deliver higher densities within the same building. The benefit here is very simple, so I can permit the building without knowing which customer will move in and what the customer actually wants to deploy in the building. Because the building design has multi-purpose rooms that can be used for liquid cooling, that can be used for air cooling, that can be used to different setups to allow us to deploy different concepts. It's also already built on the base design requirements of all our big customers, so all the big hyperscalers. So it's already meeting between 70% and 80% of their base requirements, and it already brings that forward as part of the base design. So we can permit a base design that meets the majority of all the customers' requirements, and then later in the process, pivot to their specific needs. That just improves the time of delivery substantially. What it also does, as I said earlier, we source all key equipment through master supply agreements on a central headquarter level. So we have secured supply chain for future set of data centers that we deploy, because no matter what will go into the data center, we already know that we source components that can deliver to all those specific models. And the benefit of this Magnus design philosophy, it can even evolve in the future. So we now have the challenge, as I explained, that we see high demand for high performance GPUs, for components that we don't really know, because the average data center development in Europe is between 3 and 4 years. So we don't even know what kind of chipset will actually go into the data centers that we design and build today, because they will only be ready for service when a next generation of GPUs is out there, or maybe not even GPUs will be deployed. It can be TPUs, other component, whatever the need be. And that design philosophy, we're currently already putting into a second version that we call Magnus 2.0, that delivers the same design philosophy that we have today for rack densities up to 150, 200 kilowatts, starting from more or less nothing like 2 in the same building, to take it to the next level where we will be delivering 450 kilowatt, 600, 650 kilowatt racks, or even megawatt racks within the same building. So it's the same concept. So you build that one building, you permit that one building, and you can deploy those real high density racks next to another traditional storage or network deployment. And we believe that that is the most essential part of the future and current skill set, is to pivot and find the perfect spot between standardization for speed of delivery to secure the supply chain, and also customization for the latest hardware components that the customers want to deploy in the white space, but also to really adopt to their specific requirements. Also very important, because the recent designs of our hyperscale customers, which in the past have changed every 2 or 3 years, are currently sometimes changing twice a year. So there's a constant evolution. We will put this into life in all of our campuses. A great example is our Milan campus, and this just shows MXP2. It's our second big data center project in Milan. We just announced this morning that not just the land acquisition has closed, but we've already started to design and permit this building, so it's well under construction. We will be investing more than 2 billion euros in the Milan market, and a substantial lot of it in this specific campus, which will be ready for service in 2028. And this is exactly where this philosophy and this concept will come to life. So if you check our press releases, you will see that we're talking about a 120 megawatt IT campus, either delivered in 2 60 megawatt buildings. It can also deliver in 3 40 megawatt buildings. It's the same principles. It's a base design principles, like in the Volkswagen car, that can adopt and can pivot, so we could potentially put 2 customers, 3 customers in the same piece of land and deliver their specific requirements. We believe that is the future. It's a mixture of standardization to deliver at speed, and also customer adoption and flexibility. And we will continue to develop the Magnus project, and we'll obviously love to see you in one of our data centers. Thank you.